Present value. If you want to invest money into an account to have a certain value in the future, the present value is the amount you must invest today to reach that goal. Given our compound interest formula, which is A equals P times 1 plus R over N raised to the NT. A is the amount we're going to have in the end, our future value. P is the amount we're going to invest today. So it shouldn't be too hard to see that if we divide both sides by this glob, we get that the amount we have to invest today is the amount we want divided by all this stuff. Now that formula looks kind of scary, but it's not too bad if you think of it as the effect of the compound interest, which is the glob I mentioned earlier, and that's the 1 plus R over N raised to the NT. Thinking of it that way, you get that the amount accrued is the principal times this glob. And notice when I've been calculating this so far, I've been calculating the glob separately and then multiplying it by the principal. Likewise, the present value formula becomes P equals the amount you want over the glob. So we'll still just calculate what the glob of stuff is, except instead of multiplying it by the principal, we'll divide the amount we want by that glob. Let's just try it and see. Will would like to send his daughter to attend college in 6 years when she finishes high school. Will would like to put enough money back now so that she will have $30,000 at that time. If he finds a CD with an interest rate of 2.5% compounded quarterly, how much should he invest now? And we again have the present value equals the amount we want to have divided by our glob of stuff. So we have the desired amount, $30,000. We have our interest rate, 2.5%. And we have our compounding quarterly, so that's 4 times a year. And he's down to 6 years, so T equals 6. So our present value, the amount we need to invest, is going to be 30,000 divided by 1 plus 0.025 divided by 4, all raised to the 4 times 6. So if we attack this the way we did before, I'm going to look at this glob in the bottom first. 0.025 divided by 4 equals, plus 1 equals, raised to the 24th equals. At this point you can either write that down, whatever's on your screen, or you can save it to memory, do something like that, because we're going to need to take 30,000 divided by whatever that number is. Let's see what that number is real quick. One plus 0.25 divided by 4 raised to the 24. Okay, I get that the glob is 1.161292018, and it keeps going on. This is an ugly number, and it's going to be. That's why I would suggest if you've got a store button on your calculator, save you from repunching all that in. Now we'll type in 30,000 divided by, now on mine I actually have an answer button, so I can say 30,000 divided by the previous answer, and it'll automatically stick in that number. equals, and it tells me that I need to put in, yikes, $25,833.30. That's kind of scary. All right. The effect of compound interest. Let's just do an example. If we have $100 invested at 6% compounded monthly. We've done these before, but just for fun, $100 times 1 plus 0.06 over 12 raised to the 12 times 1. And when we do that math, we get that our ending balance would be 106.17. Okay. Now, if we had just had simple interest, we would have had 6% times $100, or $106. So if we had done simple interest, it would have, our ending balance would have been $106. We've actually made more than that. And the effectively, if we had had a simple interest loan, it would have had to be at 6.17% interest in order to get the same amount. What we want to be able to do in order to compare apples to apples, oranges to oranges, when we're looking at simple interest or compounded monthly, compounded daily, or whatever, in order to get an accurate comparison of all these, we're going to look at the effective annual yield, or you'll see it written as the annual percentage yield, or APY. That is the simple interest rate that would give you the same amount of interest over the same period of time. So if you were not compounding, if it was just simple interest, what would the interest rate have to be? The formula is just the glob minus 1 with t equals 1 year. Or more precisely, 1 plus r over n, all that raised to the n, and we'll subtract 1 from it. And then that'll give you a decimal. You can turn it into a percentage, into a percent. So what is the annual percentage yield for an investment at 12% compounded semi-annually? So we'll do 1 plus 0.12 divided by, let's see, semi-annually would be twice a year. And then we'll raise that to the second. That's the glob. And then we'll subtract 1 to get it to the amount that it's actually increased. And when I do that, I get 0.1236, or 12.36%. So the annual percentage yield is 12.36%. That's how much you would have to earn in simple interest to match this compounding. What about monthly? Well, 1 plus 0.12 divided by 12 raised to the 12th, and then subtract off the 1, and we get 0.1268. So 12.68%, that's just a little better. Alright, what about daily? And again, we're going to use, because of the banker's rule, we're going to use daily as 360. So we get 1 plus 0.12 over 360 raised to the 360th power minus 1, and I get 0.1275, which is 12.75%. That gives you an idea of the benefits of the different compoundings. You get a good jump for going to twice a year compounding, another little jump for monthly, not quite so much for daily. there's our APY.